Hello everyone, welcome in the solution session of integration by part. It is mainly used as a product and it is also used to find out integrable terms like logarithm and inverse trig functions. Here we have to integrate x into sine 3x. The first function is algebraic function and second function is a trigonometric function. So if we go from the right side of the islet, we will get algebraic function first and then trigonometric function. So we can say your algebraic function will be selected as a u and trigonometric function will be selected as a v. Let's try to apply the formula. Your u is as it is. We have to integrate sine 3x minus integration of product of differentiation of u, which is x, and integration of v, which is sine 3x. Now let's simplify. X is as it is. Integration of sine 3x will be minus cos 3x upon 3 minus integration of differentiation of x will be 1 and integration of sine 3x will be minus cos 3x by 3. Now let's simplify. Our first term will be minus x cos 3x upon 3. In second term, before we go for integration, let's simplify and multiply. This minus become plus. Let's take it 1 by 3 outside and we just have to integrate cos 3x. Now your first term still remain as it is plus 1 by 3 will be as it is. Integration of cos 3x will be sine 3x upon coefficient of x, which is 3 plus c. You can consider this as a final answer. Ta-da! Here we have to integrate x into sine x. X is algebraic term and sine x is trigonometric term. If you go from the right side, we will get x as a u and sine x as a v. So we are ready to apply the formula. In first term, your x will be as it is. We have to integrate sine x minus in second term, we have to integrate the product of differentiation of u, which is x, and integration of v, which is sine x. Now let's simplify. Your x will be as it is. Integration of sine x will be minus cos x minus integration of differentiation of x will be 1. Integration of sine x will be minus cos x. Now your first term will be minus x cos x, and if we simplify the second term, minus become plus. Cos x into 1 will be your cos x. Now your first term will be as it is plus integration of cos x will be sin x plus c is your final answer. Ta-da! Here we have to integrate x into log 2x. So we will try to apply partial fraction. Your x is a algebraic term and log 2x is logarithmic term. So we have to select log 2x as a u and x as a v. So we are ready to apply the formula. In first term, your log 2x will be as it is. We have to integrate x minus in second term, we have to integrate the product of differentiation of u, which is log 2x, and integration of v, which is your x. Now let's simplify. Your log 2x will be remain as it is. Integration of x will be x square by 2 minus integration of differentiation of log 2x, or we can say differentiation of log box will be 1 upon box into d by dx of box. Within the box we have 2x, so we have to differentiate 2x, or we can say multiply the coefficient of x, which is 2. Now integration of x will be x square by 2 dot dx. Now your first term will be as it is and In second term, your 2 will cancel out and 1 power of x will also cancel out. So remaining 1 by 2 will be taken outside and we just have to integrate x. For further simplification, we can say your first term will be as it is, and in second term, we just have to integrate x, which is x square by 2 plus c. So you can get the final answer. Ta-da! Here you have to integrate x into sec square x. Your x is the algebraic term and sec square x is your trigonometric term. So we have to select x as a u and sec square x as a v. So we are ready to apply the formula. In first term, your x will be as it is, integration of sec square x dot dx, minus in second term we have to integrate the product of differentiation of u, which is x, and integration of v, which is sec square x. Now let's simplify. Your x will be as it is, integration of sec square x will be 10x, minus integration of differentiation of x will be 1 and integration of sec square x will be 10x. Now your first term will be as it is and we just have to integrate 1 into 10x, or we can say 10x. So still your first term will be as it is and integration of 10x will be log mod sec x plus c. So this is your final answer. Ta-da! Here we have to integrate x square plus 1 into log x. So we have to apply partial fraction. Here x square plus 1 is an algebraic term, log x is a logarithmic function. So we have to select log x as a u and x square plus 1 as a v. So we are ready to apply the formula. Your log x will be as it is. We have to integrate x square plus 1. And in second term, we have to integrate the product of differentiation of log x and integration of mu, which is x square plus 1. Now let's simplify. Log x will be as it is. Integration of x square will be x cubed by 3 plus x, minus integration of differentiation of log x will be 1 by x, and integration of x square plus 1 will be x cubed by 3 plus x. Now your first term will be as it is, and let's simplify our second term. If we multiply 1 by x with x cubed by 3, we will get x square by 3, and 1 by x multiplied with x will give us 1. Still your first term will remain as it is, and in second term 1 by 3 will be as it is. Integration of x square will be x cubed by 3 plus integration of 1 will be x plus c. So let's simplify and get the final answer. Log x cubed by 3 plus x will be as it is, minus of x cubed by 9 minus x plus c is your final and simplest answer. Ta-da! Here you have to integrate x into log x the whole square. Your x is algebraic term and log x is a logarithmic term. So we will select log x the whole square as a u and your x will be v. So let's apply the formula. In first term, your log x the whole square will be as it is. We have to integrate x dot dx, minus we have to differentiate u, which is log x the whole square, and integrate v, which is x. Let's simplify. Log x the whole square will be as it is. Integration of x will be x square by 2 minus integration of differentiation of log x the whole square, or we can say differentiation of box square. It will be 2 box into d by dx of box. Within the box we have log x. So we just have to multiply differentiation of log x, which is 1 by x. Now integration of x will be x square by 2. Now let's simplify. Your first term will be as it is minus integration of this 2 will cancel out. 1 power of x will also reduce. So we will get log x into x. So again, here we have the product of two functions. So we have to apply partial fraction second time. And we know that your log x will be u and x will be v. So let's write down our first term as it is. Then apply the integration by parts in the second term. Log x will be as it is, integration of x dot dx, and minus integration of product of differentiation of u, which is log x, and integration of v, which is x. So quickly, your first term will be as it is, and in second term, your log x will be as it is. Integration of x will be x square by 2 minus integration of differentiation of log x will be 1 by x, and integration of x will be x square by 2. In further simplification, your first term still remain as it is, minus log x into x square by 2 and plus, here 1 power of x will cancel out. We can take 1 by 2 outside and just integrate x, which will be x square by 2 plus c. So you can accept this as your final answer. Ta-da! Here you have to integrate x square into e raised to x. Your x square is a algebraic function and e raised to x is exponential. So we have to select x square as a u and e raised to x as v. So let's apply the formula. In first term, x square will be as it is. We have to integrate e raised to x minus, in second term, we have to integrate the product of differentiation of u, which is x square, and integration of v, which is e raised to x. Now let's simplify. Your x square will be as it is. Integration of e raised to x will be e raised to x minus integration of differentiation of x square, which is 2x, and integration of e raised to x will be e raised to x. Now your first term will be as it is, minus, in second term, we have the product of 2x and e raised to x. So we have to apply integration by parts second time. So we will select 2x as a u and e raised to x as a v. So let's apply the formula. Your 2x will be as it is, integration of e raised to x minus integration of product of differentiation of u, which is your 2x, and integration of v, which is e raised to x. Still, your first term will be as it is, and in second term, minus of 2x, integration of e raised to x will be e raised to x, and minus integration of differentiation of 2x will be 2, and integration of e raised to x will be e raised to x. Now, let's simplify. Your first term will be as it is. Open the bracket. You will get minus of 2x into e raised to x. Minus minus become plus. 2 is constant. Take it outside. We just have to integrate e raised to x, which will be e raised to x plus c. So, ta-da! You can consider this as your final answer. For this kind of a function, like algebra into trigonometry and algebra into exponential, we have the direct formula known as Bernoulli's formula. Let's integrate the same question using Bernoulli's formula. Here we have to differentiate term of algebra, which is x square. So first of all, substitute x square as it is and bracket, then minus differentiation of x square will be 2x and your bracket for the integration. Again, differentiation of 2x. So plus differentiation of 2x will be 2, and again bracket. And if you go further, like differentiation of 2, then we will get 0, and 0 into anything will be 0. So we don't need to get the further terms. Now it's time to integrate e raised to x. So integration of e raised to x will be e raised to x. Similarly, again integration of e raised to x will be e raised to x, and integration of e raised to x will be e raised to x plus c. So as you can see, you can get the direct answer in just one step. Let's take another example of, let's say we have to integrate x cube into sine 2x. So in first term, your x cube will be as it is, just write down bracket, then minus differentiation of x will be 3x squared, and bracket, then plus differentiation of 3x squared will be 6x, and the bracket, minus differentiation of 6x will be 6, and just write down bracket. And if you go further, you will get 0. So differentiation of first term is over. Now let's select the second term. Integration of sine 2x will be minus cos 2x upon 2, which is coefficient of x. Now integration of cos 2x will be minus sine 2x upon 2 square. Integration of minus sine 2x will be plus cos 2x upon 2 cube. And again, integration of cos 2x will be sine 2x upon 2 raised to 4 plus c. So we can get the answer in just one step. Ta-da! Here we have to integrate x into cos inverse x upon under root of 1 minus x square. This cos inverse x is an inverse trig term. I always prefer to assume the inverse trig term as a t, where t is belongs to 0 to pi, and its differentiation is also available within the multiplication of dx. So let's differentiate both the side. Differentiation of cos inverse x is minus 1 upon under root of 1 minus x square dot dx will give us dt. But here we have dx upon under root of 1 minus x square. So let's take this negative sign on the right hand side. So let's try to modify our integration. Here we have to integrate. Your x will become cos t, and your cos inverse x will become t, and dx upon under root of 1 minus x square will be your minus dt. Now we have two functions in multiplication. So let's apply integration by parts. Your cos t is a trigonometric term, and your t is an algebraic term. So we have to select t as a u and cos t as a v. So let's take minus outside and apply the formula. Your t will be as it is, integration of cos t minus, in second term we have to integrate differentiation of t with respect to t, integration of cos t. Now it's time to simplify. Minus t will be as it is, integration of cos t will be sin t, minus integration of differentiation of t, which will be 1, and integration of cos t, which will be sin t. Now open the bracket, you will get minus t sin t, minus minus become plus, integration of sin t ones are sin t. So here your first term will be as it is, plus integration of sin t will be minus cos t plus c. So we can say minus plus become minus cos t. Now to get the final answer, we just have to substitute the value of t. Here we assume that cos inverse x is equal to t. So we can say we will get x is equal to cos t. So using triangle method, we should find out the value of sine t. Let's assume this is your t. So cos t is actually adjacent upon hypotenuse, which is 1. So we can get opposite edge as 1 minus x square. So we can say your sine t is simply opposite, which is 1 minus x square upon hypotenuse, which is 1. So we get the value of sine t. Just substitute all the value. Your t is simply cos inverse x, and your sine t is simply under root of 1 minus x square, then minus of cos t, which we assume as x plus c. So tada! This is your final answer. Here we have to integrate x into sine inverse x, but I never like this inverse trigo term, so I always prefer to assume that inverse trigo term is equal to t, where t is belongs to minus pi by 2 to pi by 2. The differentiation of sine inverse x is not available within the multiplication of dx. So we have to make x subjective, so we will get x is equal to sine t. Now differentiate both the side, we will get dx is equal to cos t dt. So we are ready to modify our integration. Here x is sine t, so let's substitute sine t. Your sine inverse x will become t, and your dx will become cos t dot dt. Here we have three functions, two trigonometric and one t. So let's try to combine these two functions. If we multiply and divide by 2, we will get 2 sine t into cos t, which can be converted into sine 2t, and your t will be remain as it is. So now we have two functions in product. So let's apply integration by parts. Your t is algebraic function and sine 2t is your trigonometric function. So if we go from the right side, you will get t as a u and sine 2t as a v. So let's apply the formula. In first term, your u will be as it is, and we have to integrate v, which is sine 2t. And in second term, we have to integrate differentiation of u with respect to t and integration of sine 2t. Now let's simplify. T will be as it is, integration of sine 2t will be minus cos 2t upon the coefficient of t, which is 2, minus integration of differentiation of t, which is 1, and integration of sine 2t, which is minus cos 2t upon 2. Now if you open the bracket, 1 by 2 into t minus cos 2t by 2 will become minus t cos 2t by 4, and 1 by second term will become plus 1 by 4 integration of cos 2t, which will be sine 2t upon coefficient of 2, which is 2, plus c. Here we get the answer in terms of 2t, but we assume sine t is equal to x. So we have to reduce the angle to the t. So let's simplify. This minus t will be as it is. We have to convert this cos 2t in this single power. So let's convert in terms of t using the formula 2 sine square t minus 1 upon 4 will be as it is, plus in denominator we will get 8, and we have to convert sine 2t into 2 sine t into cos t plus c. Now we have all the trigonometric terms with the angle t. So using our assumption, which is x is equal to sine t, let's try to get the value of cos t. Let's assume this is your t and sine t is equal to x by 1, or we can say opposite upon hypotenuse. So we can get the adjacent edge as 1 minus x square. Now we need to get the value of cos t. which is adjacent upon hypotenuse, or you can say under root of 1 minus h square upon 1. So let's convert all the t in terms of x. Minus this t is your actually sine inverse x. Then 2 sine square t is 2t square minus 1 upon 4 plus this 2 4s are 8. So here we'll get 4, your sine t, your x, and this cos t will be under root of 1 minus x square. So tada! This is your final answer. Here we have to integrate x into tan inverse x. We have to apply integration by parts. But I always prefer that whenever you have inverse trigo term, just assume as a t. So let's assume tan inverse x as t. But we don't have the differentiation of tan inverse x within the multiplication of dx. So we have to make x subjective. So we get x is equal to tan t. Now we can differentiate both this side and get dx is equal to sec square t dot dt. So here we can modify our integration as here x will become tan t, your tan inverse l will become t, and your dx will become sec square t dot dt. Now here we have three terms, t as an algebraic term and tan t and sec square t is your trigonometric term. But here you should notice that we can integrate tan t into sec square t, because if you consider tan t as your fn, then we already have its differentiation within the multiplication of dx. So its integration will be tan square t by 2. So your tan t and sec square t is integrable term. So we will select that as your v, and your t will select as a u. Let's apply the formula. In first term, your u will be as it is. We just have to integrate your v, which is 2 sec square t, minus in second term we have to integrate differentiation of u, which is t, and integration of v, which is tan t into sec square t. So let's simplify. Integration of tan t into sec square t dot dt will be tan square t by 2, minus integration of differentiation of t will be 1, and integration of tan t into sec square t will be tan square t by 2. In further simplification, your first term will be remain as it is, minus 1 by 2 is constant, take it outside, and we have to integrate tan square t into 1, or we can say tan square t, which should convert into sec square t minus 1. So we can say your first term is as it is, minus 1 by 2 integration of sec square t will be tan t, minus integration of 1 with respect to t is actually t, plus c. Now let's convert all the terms of t in terms of x. We assume that your tan t is equal to x. So let's use our assumption to convert our answer in terms of x. Your t is actually tan inverse x. Tan square t will be t square by 2, minus 1 by 2 will be as it is. Your tan t will be x, minus your t will be tan inverse x, plus c can be considered as your final answer. Tada! Here we have to integrate sine inverse 2x upon 1 plus x square. We have to simplify this using inverse trigo. Our bracket, which is 2x upon 1 plus x square, is actually in the form of 2 tan theta upon 1 plus tan square theta, which is actually sine 2 theta, which suggests that we have to assume x is equal to tan theta. where theta is belongs to 0 to pi by 2. If we differentiate both the sides, we will get dx is equal to sec square theta dot d theta. So let's simplify. We have to integrate sine inverse of 2x, or we can say 2 tan theta upon 1 plus tan square theta into your dx will become sec square theta dot d theta. Now, as we plan, sine inverse of this 2 tan theta upon 1 plus tan square theta will become sine 2 theta into your sec square theta dot d theta. So here, sine inverse of sine 2 theta can be rewritten as 2 theta. We have sec square theta dot d theta as it is. So we have the multiplication of two functions. Your 2 theta is algebraic term and sec square theta is trigonometric term. So if we go from the right side, we will get 2 theta as a u and sec square theta as a v. So let's apply the formula. In first term, your u will be as it is. We just have to integrate your v, which is sec square theta, minus in second term, we have to integrate the differentiation of u, which is 2 theta, with respect to theta, not x, and integration of sec square theta. Now let's simplify. Your 2 theta will be as it is. Integration of sec square theta will be tan theta minus integration of differentiation of 2 theta will be 2 and integration of sec square theta is tan theta. Now your first term will be as it is, minus 2 is constant, we don't have to worry about it. We just have to integrate tan theta, which is log mod sec theta plus c. Now we should get our answer in terms of x. We assume that your x is equal to tan theta, but we also going to need the value of sec theta. So let's try to get the value of sec theta using triangle method. Let's suppose this is your angle theta. We already assume that tan theta is equal to x upon 1, or we can say tan theta is actually opposite upon adjacent. So here we'll get under root of x square plus 1 as your hypotenuse. So we can get the value of sec theta, which is hypotenuse upon adjacent, which is 1. So we are ready to convert all the terms of theta in terms of x. So your 2 theta will become 2 tan inverse x. Your tan theta will become x minus 2 as it is log mod sec theta will be under root of x square plus 1 plus c. For further simplification, first term will be as it is minus, we can take these 2 in the power of term. So we will get log of x square plus 1 plus c. Ta-da! You can consider this as your final answer. Here you have to integrate log x. As you know, we don't have direct formula of integration of log x. So we have to use integration by parts. Here, so we will select log x as your u and 1 as your v, and we'll apply integration by parts. In first term, log x will be as it is. We just have to integrate over v, which is 1 in this case, minus integration of product of differentiation of u, which is log x, and integration of v, which is 1. Now let's simplify. Log x will be as it is. Integration of 1 will be x minus integration of differentiation of log x, which is 1 by x, and integration of 1, which will be x. So now your first term will remain as is, and in second term, xx will cancel out. We just have to integrate 1. which will be x plus c. Or we can say, if we take x common, we will get x log x minus 1 plus c. So, tada! This is your answer. You can remember this as a formula. Here, we have to integrate sine inverse x the whole square. In this case, we have to integrate inverse trigonometry, but I always prefer that trigonometry is equal to t. So in this case, let's assume sine inverse x is equal to t, where t is belongs to 0 to pi by 2. So you will get x is equal to sine t, and if we differentiate both this side, we will get dx is equal to cos t dot dt. Now, let's modify our integration. Your sine inverse x the whole square will become t square, and your dx will become cos t dot dt. So now we have the product of two terms. First one is algebraic and second one is trigonometric. So we will select t square as your u and cos t as your v. So let's apply the formula. Your t square will be as it is. We have to integrate v, which is cos t. And in second term, you have to integrate the differentiation of u, which is t square, and integration of v, which is cos t. Now, let's simplify. Your t square will be as it is. Integration of cos t will be sin t, minus integration of differentiation of t square will be 2t, and integration of cos t will be sin t. Now, in further simplification, t square into sin t will be remain as it is, minus to integrate 2t into sin t, you have to apply integration by parts again, where 2t is your u and sin t is your v. So let's apply the formula. 2t will be as it is, integration of sin t will be minus cos t, minus integration of differentiation of 2t, which is 2, and integration of sin t, which is minus cos t. Now, as we know, your first term will be remain as it is. Open the bracket, minus minus becomes plus 2t into cos t. Again, minus 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 will become minus, 2 is constant, take it outside. We just have to integrate cos t, which is sin t plus c. But we have to get our answer in terms of x. So let's use our assumption, which is x is equal to sin t. But we also need the value of cos t. So for that, we are going to use the triangle method. Let's assume this is your angle t, and it is given that sin t is equal to x by 1, or we can say opposite upon hypotenuse. So we will get our adjacent line as under root of 1 minus x square. So we can get the value of cos x as under root of 1 minus x square. So we are ready to get our answer in terms of x. This t square will become sin inverse x the whole square. Then your sin t will be t plus 2 times t will become your sin inverse x, and cos t will become under root of 1 minus x square, minus 2 sin t will become your x plus c. So tada! This is your final answer.